Hello everyone, and welcome to the first lecture of programming with Mathematica. So today we'll be talking about some basic stuffs that we can do with Mathematica. In this case I'm using the Mathematica version 12, but the commands that will be shown here will work in any versions that you are using. So we want to start with the basic stuffs. So basic calculations. So in the notebook, let's first type a number. Let's say I want to type 12. Okay, I think it's a bit small, so let me enlarge that a bit. Okay, so you have typed 12. Now you want to run 12. That means you are giving an input 12 and you want to see what does Mathematica show you as an output. To see the output, what you need to do is press shift and enter. So as you can see, this in line, that means the line that is showing us in, this is our input, and this out, this is our output. So as you can see, Mathematica is giving us 12 in output. Alright, so what if I type ABCD, which has no values, and again we run the code and we can see that Mathematica is returning ABCD. So if you give some input and do nothing, Mathematica will just spit out the input. So now we want to calculate something. Let's say I want to add three numbers. Let's say 3 plus 4.5 plus 1, and run the code, and we can see that Mathematica has given us the result, that is 8.5, right? Similar way you can do the subtraction. For example, you want to subtract 30 minus 20, and you run the code, you get your answer. Similarly, we can multiply many numbers. Let's say I want to multiply 4 numbers. I will take 3, then I will take 4, I will take 5, and then I want to multiply the whole thing with 10. And as you can see, we are getting our results, that is 600. Now let's say I want to divide two numbers. I want to divide 3 divided by 5. I want to see what the result will be. Now if we run the code, we see that it's giving us 3 by 5, but not the decimal values. That is, it should have been 0.6, right? But it's not giving us that. So what happens here is that when we typed 3 by 5, Mathematica treated this 3 by 5 as an exact expression. So whenever Mathematica considers something as an exact expression, it leaves it unchanged. To extract the numerical value, we can use a built-in command that comes with Mathematica, and the command is written as capital N, and then you have to put a third bracket around it. And what does this N mean? It stands for the numerical value. For example, when you type this third bracket, you will see a red arrow, a small red arrow over here inside this third brackets, and if you put your cursor over there, you can see that this command takes an expression as its argument and gives the numerical value of expression. So let's type 3 by 5 inside this third bracket under the command N, that stands for numerical value, and if you run the code, there you go. Now you have the numerical value of 3 by 5. So in Mathematica, whenever you see an exact expression like this, 3 by 5 or stuff like that, if you want to extract out the numerical value, you need to use this N command. Okay, so now we want to learn about variables. That is, we want to know how to declare variables in Mathematica and then manipulate them. So let me write it down. Variables. Oh, sorry. So how do you declare a variable in Mathematica? So let's say I want to declare a variable and I'm calling the variable x, and I want to store a number to this variable. To do that, I want to type x equals to, let's say, 4, and if I run the code, it's giving me 4. To know whether your variable is actually storing a value, what you need to do, you need to type the question symbol, and then you need to put the desired variable just beside it. So if you do that, let's say, since I have declared x as my variable, and so I have written the question mark times the question mark, and I have written x just beside it, and let's run this code. As you can see, Mathematica gives you not only the variable's value that it's storing, but also what kind of variable that is. Here x is a global variable. And before I move on, I want to say something about cells. That is, if you look at the right side of your screen, you can see this third brackets that looks like a third brace. These are actually cells, and this is one cell, this big one, and these two are subcells. So Mathematica evaluates the code cell by cell. It's an important thing to keep in mind because it will be useful for us for later lectures and when we will deal with some complicated or really long equations. Now let's say I want to declare another variable y as 3.5, let's say. So again, I'll run the code so that Mathematica knows that y is equals to 3.5, and now I want to evaluate x times y, and there you go, you have your answer over here. And let's say you want to write 2x. Notice that I have not put any symbols between 2 and x. So I want to see what Mathematica does. Does Mathematica understand that writing 2x is equivalent to multiplying x, that is the value of x, with 2? Can Mathematica do that? Yes. The answer is yes, Mathematica can do that. So now let's say you want to write an equation with this 2x and y. So let's say I want to write this 2x plus 3y, and I want to evaluate this. I'm getting 18.5. Alright. So up to this point we have only considered very simple expressions. Now let us think of a complicated expression. And let's say I want to evaluate 4 plus 20 by 5. Now what I mean by 20 by 5 or 20 divided by 5 is that actually I want to evaluate the expression where I have 4, then plus that, then 20 divided by 5. Notice that the whole expression should not be divided by 5. And if I don't use brackets in Mathematica, I want to see what happens. So does Mathematica count 24 divided by 5? That is for this expression. Does Mathematica count it as 24 divided by 5? Or does Mathematica takes care of this 20 by 5 first and then adds it to 4? If I run this, I'm seeing 8. So what does that mean? It means that Mathematica is taking 20 by 5 first and then adding it to 4. But it is advisable to use braces if there is any kind of chance of confusions, because in some expression, if your expression is really long and complicated, then this type of thing might not occur and you might get wrong results. So it's always advisable to use braces where necessary, and we will use first braces. And now let's say instead of small x and y, now I want to declare an equation that will consist of some new variables, and I want to call this equation eq1, that is for equation 1, and I want to declare it as 2 capital X plus 3 capital Y plus 5 capital Z. So I have run the code, so Mathematica now knows it, and I want to declare another equation called equation 2, and this will look like 4.7 x plus 30 y minus 1.5 z, sorry, capital Z. Now I want to see what happens if I add these two equations, because we want to see whether Mathematica is able to identify these x, y and z's as unknowns and add their coefficients as we would do. So let's type eq1 plus eq2, and if we run it, and yes, the answer is yes, Mathematica is successfully treating x, y and z to be symbols, or let's say some variables, some unknown variables, and that's why you get this expression that says 6.7x plus 33y plus 3.5z. Now what if we change this structure for a bit? That is, I want to type x to the power 2. Can I do that? And remember, since I'm editing this code right over here, I need to run it again, because otherwise Mathematica won't remember it. For example, if I still type equation 1 plus equation 2, you see that result is not changing. So Mathematica is keeping this value in its memory. But when I write this square over here and run this cell again, you can see that now the value for equation 2 has been changed. So now let's run the code again, and as you can see, 2x plus 4.7x squared, 33y plus 3.5z. Now let's say I want to have an expression that consists of multiplications of this equation 1 and equation 2, and also equation 1 divided by equation 2. That is, let's say I want to write some random expression. I want to call it, let's say, equation 1 plus equation 2 squared, and then I want to divide this by equation 2. So what does Mathematica give me? Let's see. As you can see, it doesn't look really different. So something must have gone wrong here. So what could possibly go wrong? So let's try it another way. First, I want to see that what does equation 2 squared gives me. Equation 2 squared. As you can see, this is my equation 2 squared. Alright. And it's not expanding these terms. We will see later how to expand these terms. So this is my equation 2 squared, but there is another way we can write this square in a very elegant format. To do that, press Ctrl and put the power sign, and as you can see, above equation 2's head there will be a small box, and you can type the number you want. So in my case I want to type 2, and then I run the code. Yeah, this is the same output. Now I want to, let's say, add equation 1. Let's see what happens. As you can see, it has added equation 2 square with equation 1, but it has not simplified or expanded this term, that is on the term of a squared, something whole squared, right? And now we want to divide it. To divide it, we can type this, or again you can do it in a very elegant form. To do that, you need to type control and the division button. And as you can see, since my cursor was at this place, it brings up a fractional form at that place only. So what I need to do, I need to put some braces over here, that is on left and on right, and then I can press control the division button, and in the later box I want to type equation 1, or yeah, that's what I want to type. Okay, and run this code, and as you can see, it has given us this thing, but it hasn't simplified anything. In the later lectures we will see how to expand them and how to simplify them. So for now we have been dealing with this x and y's only, but let's say I write something, a variable. By something I mean a variable. Let's say I want to call my variable apple equals to 3t plus 5m. Alright, and before apple I want to actually declare t equals to 2 and m equals to 1. And notice that I have been putting semicolons this time. The reason will be apparent very soon, and I am not running any of them because I'm just only pressing enter and going to the next line and writing the expressions that will be relevant for me. So I wrote down a new variable called apple and put a semicolon over there, and then I want to type, let's say, bird, which is equals to, I want to type a fractional variable now, so I want to type 2 by 3 m minus 5t. I'm just taking these numbers up at random, and apple bird, and let's say I want to type another variable called tiger. But in tiger I want to introduce something called u, and I want to put 1.5 here. U plus bird minus apple. As you can see, writing these 5 lines I have used semicolons in the first 4 but not on the last. So what does that give me? Let's run it. As you can see, Mathematica actually gives me the value of tiger. What it does is that it takes t equals to 2, m equals to 1, then it evaluates apple. After evaluating apple, it evaluates birds, and then it uses the values of apple, value of apple and the value of bird. Mathematica puts them into the tiger and finally prints the result that comes from tiger. And notice that even if this u was not defined, that is, you were not assigned to any number, Mathematica still treats it as a symbol that is an unknown and puts it there. So what you can guess from here is that whenever a symbol comes in a blue font, Mathematica treats it as an unknown. So this is one indication of it. This technique will be, or this reminder will be useful when you want to deal with a long complicated equations where there will be known things and there will be unknown things, and if you have to look for some unknowns, you can easily check them by using this color formatting. So far so good, we can do this kind of stuffs. So let's now look at some of the commands that we get from Mathematica, and we will only be seeing one or two today, and as we go on we will learn some new commands. So I want to have a section for this, some built-in commands, useful commands. So the first command I want to share is that the expand command, that is exp, and if you write expand, as you can see Mathematica is already suggesting that I should use this, or do I want to use something else? So what does this expand command do? Let's see. Let's say you want to write a plus b squared, right? And if you shift enter it, it just returns you the same thing, but it doesn't return you a squared plus b squared plus 2ab, right? So the way to get that full expression is to use expand. As you can see, I've typed x and it is already showing me the expand command and some other command, that is exp, exponential data export, and a lot of other things if you click on the down arrow. So let's use this expand command, and first you have to put this third bracket. So whatever the argument you want to give, it will come inside this third bracket. And again, to view what this command does, you just put your cursor inside the third bracket and this should pop up that expands out products and positive integer powers in expression. That is, if you have an argument, this expand command will help you to expand these products. Okay, so I want to do this a plus b whole square, and there you go, you have this a squared plus 2ab plus b squared. But what if I want to do, I just want to see that whether Mathematica can do this, a plus b to the power 30, right? Let's try it. As you can see, just in a matter of, not even in a matter of seconds, but in a matter of milliseconds, Mathematica has computed all the coefficients and all the terms that comes in the expansion of a plus b to the power 30. But what if I want to do this, a plus b to the power 3 plus a plus b to the power 4? Can Mathematica do that? Let's see. It should work, and as you can see, it has worked. And note that Mathematica has also added the coefficients that comes from the similar powers. So this is a great thing, a nice thing. And so we saw so far two built-in commands. One is the numerical and the other is the expand. And there is another command called simplify, but I don't think today it will be that relevant. It will be shown later how you can use that command to simplify your complicated expressions. But let me just show how to use simplify, but for that I need to introduce some more things. That is, I will introduce to you the sine and the cosine function that we all know from our trigonometry classes. So how do you type a sine and cosine functions? So to type sine, just press capital S, IN, just write sine, and as you can see, it's already showing you the suggestion, and type a third bracket. So in Mathematica, whenever you want to put an argument inside a command or inside a function, you always have to do it in terms of third brackets. So I say I want to do sine, let's say I'm not taking small x, just so you guys don't get confused. I want to take sine p. Okay, and then I want to take cosine p, and I want to do the following. I want to see what is sine p, sine p squared plus cosine p squared. Notice that we haven't written the squares over here, that is, we haven't written this thing, we haven't wrote it like that. The reason will be evident very soon, because if you write it like that, Mathematica will show you an error. And don't get confused by putting the square over this third bracket, because it doesn't mean cosine p squared, because p squared, if you wanted to write cosine p squared, it should have been written like this. Alright, so I have this sine square p, cosine square p, and everyone knows sine square x plus cosine square x is equals to 1. So let's see what Mathematica tells us about it. And as you can see, Mathematica is not giving us 1. So how can we get 1? Because we know this is true, right? So it should be true in Mathematica as well. The trick is to use simplify. As you can see, you just type simp and Mathematica will show you some suggestions. So let's go for simplify. Put third bracket here. Again, put your cursor over there if you want to know more about this expression. And you can always click on information that pops up as an eye, and you will see that a documentation will open up and it will give you these commands. That means, what does this command mean? That is the simplify, and what are the uses of this thing. For example, today we will be only seeing the expression that is performs a sequence of algebraic and other transformation on expressions and returns the simplest form it finds. And the second one you will see over here is that it is simplify. First you give an argument, that is expression, and another argument, that is your assumption. And here you can see some of the examples. You can always look at them if you get confused. And let's cross it first. And we want to, let's say I want to now assign it to a variable just for simplification. But then again, I have to run this code, right? Otherwise Mathematica doesn't know what v is. So now Mathematica is taking v to be sine square p plus cosine square p. So I'll just type v and let's see what happens. As you can see, this is 1. So what we have done today is we learned some very basic algebraic manipulations, and we saw these 3 built-in commands to be precise. One is how to get the numerical values, how to expand, and how to simplify. So let's now take another example, but this time we'll be focusing on how to get numerical values of trigonometric functions. Let's say I type sine and I want to see what the sine 3 gives me. As you can see, it's not giving you the exact numerical value. So to do this, just type n, type sine, and then type 3, right? So you just put this sine 3 under the expression of the n command, that is the numerical value command, and you shift enter, and there you go. You saw that the numerical value of sine 3 is like this. And before we call it a day, I want to show you that Mathematica can deal with special symbols and various kinds of physical constants, that is like pi, h, whatever you want, this standard physical constants. So I want to have another section, physical constants and special characters. So we know that pi is a physical constant, right? The circumference of a circle divided by its diameter. So how do you write pi in Mathematica? So to do that, there are 2 ways. The first way is to write backslash, then give one of the left third brace and just write capital P I, and as you can see, it will give you some suggestions, and close it with the right third brace, and there you go, pi. If you run this, it just gives you pi. It just returns you pi. It's treating it as a symbol, right? But then again, we know how to get the numerical value. So, oh sorry, it just went outside. So if you do this, you can see that it's giving you the numerical value. Similarly, you can type the Greek symbols. For example, I want to type alpha. So how do I type alpha? Again, to type any special character or the symbols, first you type backslash, then you give the left third brace, and you start with a capital AL. As you can see, Mathematica is showing me suggestion again. If you just enter on it, it will type alpha for you. And as you can see, this is just alpha. What if I do this? I want to do a multiplication. 2 alpha plus 3 star, that is the multiplication, and beta, right? It gives me the same thing. So Mathematica can deal with these special symbols as well. And the second way is to type escape button. So when you type escape button, you see there is a something like a colon. I don't know what it exactly is, but a special kind of cursor point will appear, and then if you want to type pi, you just type pi, and you can see from suggestions that this is the pi. If you just enter on it, there you go, you can write pi. Let's say you want to write the exponential, that is the Euler exponential. I think it's called Euler exponential, yeah. So the exponential can be typed by pressing escape first and just type E1, and as you can see, lots of suggestions are here, so you can just cruise over them by using your keypad. And the first one is epsilon, so this is not what we are looking, right? To get this exponential e, one has to write double E. So if you just type double E, you can always enter from here, but you can always type double E and then escape again. And as you can see, so here pi and e, they are multiplied to each other, right? And let's see if Mathematica gives us something. No, because Mathematica is treating it as a symbol. Just to get the numerical value, we do the following that we learned. So I'll just copy it and paste it over here, and as you can see, Mathematica gives us the numerical values. There is another way you can type the exponential, and that is type capital EXP. This EXP, you type it, you put third braces on, and look at that. EXP gives the exponential of the argument, the whatever argument that is. For example, it is saying Z. Let's say I want to type EXP of 2. So what does this give us? E squared, right? But then again, to get the numerical value, what you have to do, you just have to put this in over here, and there you go. So this will be it for today, and I will see you guys on the next lecture. Thank you.